Okay, hello everyone. Welcome to the third roadmap discussions. If you've attended it before, I think it's very productive. We have had 30 minutes and 3 presentations of 10 minutes each. To the extent you can, try to stick to the timing because it's pretty tight, and leave some time for question and discussions. Everything is recorded. It will be posted on YouTube, and the slides, if you agree, will be posted on Slack. So the first presentation is by Manuj, and it's with address gaps with offset conversions across broad sets of models. Take it away, Manuj.
Okay, you can see my screen, right?
Yes, we can.
Yeah. Okay, so yeah, Manuj, I'm Manuj from Intel, and I don't know if Arpana had joined, but we are in the same team with Rajeev. And currently I own the ecosystem enabling with ONNX, especially with our partners. So software vendors working on the client side. So I'll go over some issues gap, which we are working with. It's large set of customers, not just one customers. And as they started adopting ONNX model, we are seeing some of the issues or gaps in the conversion side, right? So one of the basic problem we are seeing is the offset conversion. As new use cases are keep coming and there's a backlog, you can say, once they deploy in production, these companies, ecosystem partners, they don't go and keep updating the offset because they are not working with the at pace of research in production. So they are facing multiple issues on offset conversion from either going from 7, 10 to 13, because we need 13 for quantization, which I'll go through. But that is one of the common issue we are seeing is once we get the model from our customers, they're not able to we are not able to convert, or either they are not able to convert to newer offset. And we did try some workarounds, which was filed under this issue, but none of them also worked for us. I think there was a offset converter or unit test was added in 1.10.1. And that also has some, I think it's have some gaps which are not able to convert these models which have very old offsets. Okay, and this becomes, as we are not on offset 13, several customers are not on offset 13. We are not able, it's a showstopper or blocker for them to start doing the work for quantization. We want them to move to int 8, leverage good performance on it's available on many different hardware vendors, but they are not, as they're not on 13, they have to stick with FP16 or FP32, which they are deploying. And int 8 has become a bottleneck for it. Int 8 adoption has become a bottleneck. So the feedback we get from customers is they can go back to PyTorch code if they want to convert it, right? If they're using PyTorch, but as the researchers have moved to different projects or they're not in their own company, then we are at the end we are only with the ONNX model, and that means that we are stuck at that place. So the request is to see if we can solve this issue of offset conversion or have better unit testing in the future ONNX conversion side, a converter. So we are able to move older offsets to newer, so we can take advantage of performance, good accuracy, and also, of course, int 8 quantization. The other part which we also see, like I called, if we are able to convert these offset to 13, I have seen is these models, and this may be again related to the unit test. The Python verification tool says this is corrupted model, even though we have converted. So first stage is it should have not converted itself if there was an issue in the offset. But that is another common issue. So the unit test or all the tests related to every operators or layers are not to the point where ISVs are happy, like they're not happy with the ONNX side. And that's why it is, if I see currently most of them are on 10 or 9 offset. And this has not just scale customers, tier 1 customers are the ones we say they have big market share in the company for creators or in collaboration, video collaboration use cases who are adopting ONNX. and that has become one of the bottleneck. Plus, Arpna has some feedback, like going from one offset to another offset, we have to go through another offset, right? Because there's some layers which are not supported. And that also ISV feedback is why we need to do this, right? I mean, they don't have expertise or time, but these are more developers who are integrating AI and shipping in their application instead of their researchers side. So what their feedback is why we cannot convert from one offset to directly offset 15 for the use cases they are doing. Of course, they are models which can convert, but there are many models which we are not able to convert from one offset to directly to the latest offset. So if we are able to fix that, the adoption of ONNX with the latest offset will go higher. And this all comes to at the end is how much correctiveness of these tools or conversion tools are there right now, or how the unit test is implemented. Because if we are having these kind issues, which are very common, we are seeing in the ecosystem, yeah, at the end, it will hurt the ONNX adoption with the new, like optimized stack, right? New offset will be coming. We want them to go to new offset for new use cases, but it will have hampered the adoption side. So for us, as request is on the tool side, if we can find some solution to fix these conversion tools and make sure it's very seamless, at least functionally, it should work. So Rajeev or Arpana, if you want to add anything.
Aparna, do you want to bring like any examples of the issues you have faced previously?
Absolutely. Can you hear me okay on the bridge?
Yes, we can.
Yeah.
All right, cool. So a couple of models we had tried converting specifically with the ResNet 50 model and also some of the BERT-based models from the ONNX model too. And the issue that we had in such cases was the offset conversion. So for example, if we are jumping from offset 6 to offset 11, it goes through intermediate offset conversion. So it just goes from 6 to 7, 7 to 8, 8 to 9. So if either of those intermediate steps are missing, then in that case, we are missing some features to run the model in our inference. So we had such issues where the ONNX adapters were not implemented, and we had to kind of do that testing ourselves to resolve those issues. The second example that I mentioned, for example, BERT, the BERT-based model is still having issues. One, because it has a squeeze operator for which the adapter is not yet implemented. So I guess one of the biggest issues that I have seen with the version converter currently is maintenance of the tool itself. Is as we keep adding operators to the ONNX repository, it's going to be difficult to maintain the offset versions going from 6 to 11 because, or even higher, because I think we're almost at 16, 17. So jumping every intermediate step is going to be very difficult to maintain. So that was one of the issues that we did observe while doing the offset version conversion.
And I would like to highlight the fact that Manoj mentioned, right, like the creator segment as well as some of the intelligent collaboration. That's where we are facing all of these hurdles with respect to trying to push a performant model which is quantized, and some of the issues that we are running into preventing this transition.
Yeah, yeah, go ahead.
I have a quick question. So do you believe this, you know, you want better coverage? Can you share the models that breaks, or is there, in your opinion, enough models out there so that we can test whether it works? Because often, you know, you want coverage, but it needs models to go through.
Yeah, I can bring companies get the approval, at least one model, because it's one of the top creator company. So I have already shown them this. Means if you see the bug, or I added to the bug someone opened, but I put as an ecosystem partner because I don't have approval, but I can try to get one model which is failing. Actually, all of their models are failing, that's why they are not moving to new Opset. So yes, I can follow up with them and try to get, and if not, we can create a proxy model, and that should not be an issue.
I think that'll be certainly helpful to the developers.
And other part which has improved, which we with 1.10 is the FP16 conversion, and that was one of the gap between other IRs which are on different ecosystem, especially on the mobile side. They are deploying FP16, but on the Windows side, they are not deploying FP16. The reason was the conversion, but with 1.10, and there are some Microsoft converter tools which have been recently updated. It's not on the same repository, but we are seeing those issues have started getting fixed. It's not only Opset conversion. Before it was FP16 also conversion issues, which has improved recently.
Last question: which seg is responsible for that? Is that the like the converters?
Rajeev, is that do you know?
I think it comes under the domain of operator seg, if I'm not mistaken. I see Rama is here. Probably he can advise.
I don't think so. So you're talking about the Opset conversions, right?
Right.
Yes.
So, I mean, in some sense, it's almost a standalone, I think, but I would say it's probably belongs to the architecture, infrastructure. So, but I mean, I'm not sure if it. I mean,
Okay, we'll follow on this one. We'll follow up on this one. No problem. All right, let's go to the second presentation in the interest of time. And according to schedule, I think Rajeev, it's
Can you?
yes, we can see the model.
I can see the presentation. Okay, this is Rajeev Nalawadi from Intel, and the request here is essentially related to the model zoo, and one of the requests is essentially there is a good coverage for inference as of now for all the models across different categories, and with the inclusion of ONNX operators for training, Model Zoo believe we should be covering a few models samples for training scenarios as well, and maybe start it out small, like we were thinking probably any category would help getting this thing going, but from our side, preferably like transformer or NLP training samples would be the first priority, at least from the way we are engaged in the backend workloads. So ultimately, like starting out with transformer and NLP models, which can showcase training and then move over to at least having more than 3 model samples would be providing like enough starting momentum to showcase the differences as well as the similarities. And I think also we'll be setting like a path to show the distributed training infrastructure with other libraries and communication primitives that are out there in the industry. With training, I think with we can show the various techniques of data model parallelism and pipeline parallelism as applicable. And ONNX has a very good opportunity to showcase these by providing at least some of the ONNX models for training itself. And the other big area that we are seeing a lot of involvement is the quantization-aware training. And again, that is another thing which kind of quantization-aware training scenario. We would also like to request the original FP32 model, so that will allow for better accuracy comparisons. And also in the context of quantization-aware training, mixed precision is also becoming prevalent. And we have another request probably for the next roadmap session on how do we reflect the mixed precision usage in the models, like a proposal out there for roadmap. There is an opportunity to showcase mixed precision usage for training with these ONNX models as well. So I think main thing is at least start out with one sample, moving over to distributed training as an example with various backend libraries of collectives, and then quantization-aware training, and literally like the mixed precision usage, the combinations of FP16, FP32, or bfloat 16 and FP32s, or indate FP32s. We are seeing a lot of these combinations come out there when most of the models are being considered for performance improvements.
Are these samples ones that you would be willing to contribute?
The first priority, as I mentioned, we can certainly contribute with one of the transformer samples. We are working with one for our backend, hardware backend. And would like to request help from the community if there is other popular categories that can be contributed. That would really be helpful.
No, all of our training work is with transformers.
Oh, perfect. Alex, that's all I had actually.
Okay, wonderful. Thank you. Any other questions from the community?
Oh, I was just, this is Calvin here from Light Matter. With respect to quantized-aware training, one thing that sometimes matters is, the precision of accumulation often needs to be higher than, the input and output precision. So that might be something that we need to enable with ONNX model format.
Thank you, Calvin, for bringing that up. Next roadmap session, we do have one of the proposal there is how do we better reflect the usage of mixed precisions within a model as part of metadata. I'm trying to give out more, probably next roadmap session will bring in a detailed proposal from our side.
Cool, awesome.
Excellent. So good plug for the last session. Wonderful. All right, so let's move to the third and last presentation today. The floor is all yours, Rodolfo. And we can see your screen. But we cannot hear you, so I'm not sure if you're muted.
Okay.
Yes. Yeah, that was a good guess. I'm gonna need. Okay, so yes, so this is a description for a deployment configuration that we are starting to take a look at Intel. My name is Gabe Esteves. I work with Rajeev and other of the members of this forum. So thank you for the opportunity to describe this. So so let me ffirst just very briefly touch on to the actual characteristics of these training / inference configuration. So we are for the purposes of this presentation, I'm kind of interchangeably calling distributed and federated learning, but the topic or the name that you will see most often associated with this specific configuration is federated learning. And like the idea is that you would do some learning at the edge. So you deploy your model onto a fleet of devices, and and those devices just carry not only inference, but they have a training loop themselves, which it has implications on the plasticity of the model. So they enrich the model with the data that they are seeing. So the advantages of doing training at the edge are like well documented. And so here I have a like a by no means comprehensive list, but like important things include like privacy or like the technical considerations as latency, efficiency, or like use of computational resources that would otherwise go underutilized, and that sort of thing. So the idea of distributed or federated training in this is that you have each of your device include as part of like one or several configurations of training the capability to modify, to update the parameters of their model, and to also notify a server that how the model has changed. The server would collect like a bunch of such notifications, and then average them or otherwise consolidate this into a new model that includes these findings from the edge devices, and broadcast the new model for the edge devices to continue with this. So if in the specific case of ONNX, the way that this looks like in a block diagram of how this would look like, it's similar to what I have in the slide here. So once the application receives the model from an update, they carry out their basically like the pre-processing and inference loop as normal. Then they somehow updating their own model with a training, like a local training loop at the given intervals. They update their parameters to the server, and the loop and like rinse and repeat sort of deal. So as you can imagine, this sort of configuration is not this well, like, I mean, this is not an original proposal. That federated learning has been of interest for some time now, and I think since like about 2017 or so, like has started to gain traction, and we're starting to see deployments of these or encodings of this configuration in other frameworks. So to make ONNX relevant in this space, what we're proposing here is like some modifications. I mean, to the ONNX format, or to the ONNX attending libraries, so that to facilitate this particular deployment using ONNX. We believe that you can do federated learning with ONNX pretty much as it exists, but there would be some modification that would make the user experience, like the user as in like the developer of such application, more likely to use ONNX if these modifications or these facilities existed. So in particular, we believe that a minimal set of additions to the API of ONNX would consist of is basically a way to query to get the parameters of the local model, to update those parameters, and most importantly, it's some conventional or at least agreed upon metadata format, so that we could very much like we would in like transfer learning, annotate what parts of the model are allowed to change from a learning or from a local loop that would presumably be trained with a much smaller data set than the one that the original model was trained on. So as you can imagine, like the full system or the full implementation of such a system has multiple design decisions, design points, and so the idea, or like a minimal set of desired characteristics of making such inclusions in the ONNX spec would very much leave a lot of these desired design points out of scope, so that the application specific decisions can be made, and basically we would offload all of these decisions to the implementers of such a system. But there are some things that I think that would make it, if they were included in the ONNX spec, they would facilitate like kind of the basic infrastructure without limiting the flexibility that would be needed for application developers. Like the three items on the list that I mentioned before are such, but also like this notion that if you're distributing your model across a fleet of devices, probably some consistency in what version of the model you deployed, as in the same model would have to have undergone the same optimization. So you cannot, or it's not clear how would you deal with parameter updates when some of your devices are running a quantized model, for example, versus a non-quantized model, and that it does those outstanding questions. So those set of concerns seem to be more appropriate to encodings inside the model, rather than decisions left for the implementer of the higher order, the higher level system. Yeah, but while still being mindful that in many of these cases, it would be very useful to have the kind of a mixture or at least not mandate that in the federated learning system only ONNX models are allowed to participate. So yeah, as long as the architecture the model architecture is consistent, and some edge devices would be allowed to have a TensorFlow model versus others using ONNX, as long as the parameter update makes sense for both of these options. In any case, this is my intention in presenting this is kind of soliciting feedback of whether there is an interest from the spec designers to pay attention to this sort of configuration of learning, and whether they would be open to further discussion on this. And I made it to 6 p.m.
Thank you very much. Good presentation. Any questions, comments for this presentation?
Yeah, thanks for bringing this up. I was actually curious if you tried to do this with ONNX runtime. ONNX runtime supports training, and I believe we've had some folks who've built some prototype or proof of concept of doing federated learning using that.
Oh, I'd be very interested in learning more about that. If
that may help you.
Yeah, absolutely. Yes, if you mind could you send a link or some reference or something that I can follow up on?
Yeah, I don't know if it's on GitHub or anything, but we can connect and talk about it and see if what was done matches what you're trying to do.
I'd appreciate that. Thank you.
Yeah.
So Rajeev, I don't know if you want to add something to this.
No, Gabe, I think you have covered it. Thank you.
Any other questions from the community? Well, if not, I want to thank the speakers. You guys obviously put a tremendous effort in the presentation, and that's really very much appreciated by the community. And we'll be looking forward to the follow-on. So the goal is to basically present, to have those ideas presented to the relevant SIG for further detail and proposals and eventually implementation. So we'll look forward to your continued involvement with those ideas. Thank you so much. So the last session is going to be on October 1st, and we'll see you there again. Thank you so much.